All right, guys, we're going to run through three problems here off the 8.1a worksheet. Now, if you couldn't figure this out already, the A worksheet was just what was covered in part one of the video notes from 8.1. We're just talking about simplifying radical expressions here. So I skipped number one because I thought that one was pretty easy for you and thought we'd go to number two, which was a little bit more challenging. Now, as we're doing problems like this, there's probably a couple things to say ahead of time. First of all, look, guys, the answer is right here. Okay, it's 8 times the square root of 6. But I'm going to pretend not to see that so that we can approach this problem in a way that's a little bit more like we're going to see on either a quiz or a test. Now, 384, to my knowledge, is not a perfect square. So what we're going to try to do is look for a perfect square factor that divides evenly to it. And what you guys want to do, if you haven't already, is make that list of perfect squares that I wrote down in the 8.1 notes part 1. You want to have that handy. I'm going to run through some of it right now. Our list of perfect squares started with a 0 and a 1, and then it went to 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on down the list. So I'm going to write a few of these here. 49, 64, 81, and 100. Probably not going to be too much bigger than that. So what we're doing is we're looking at this original radicand here of 384, and we're trying to find a perfect square that divides evenly into it. Now, the one thing I got to warn you about is that people tend to look at this list and to read it going from top down to bottom. That is not the way you want to do that. You really want to do the opposite here and run it up this way. So the first thing I told you guys to do was to take your radicand and cut it in half. 384 divided by 2, I'm doing on my calculator, is 192. That's not a perfect square, but we should be checking perfect squares smaller than 192 to see if 384 divides evenly by them. Well, as we're running through this here, guys, the first perfect square smaller than 192 is 169. But, little hint, odd numbers like 169 never go into even numbers like 384. So even though there's a few more perfect squares to think about here, 169, I'll stop right there. I already know that the odd numbers are not ones that I need to consider here at all, because this is something worth knowing. Well, one special. There is no way that odd numbers divide evenly then into an even number like that. So anyway, the 169 does not work. 384 divided by 169, and I get something messy. Let's try 144. 384 divided by 144. Nope, that one didn't work. How about 121? 384 divided by 121. That did not work. 100, I think, is pretty obvious. That one doesn't work. 384 divided by 81. That's a no. And 384 divided by, and I think we're finally in business right here, divided by 64, it works out to be 6. That's the first one that worked out evenly. So there's no secret to this other than just doing the grunt work of grabbing your calculator and dividing your radicand by these numbers here and working up the list so that we find the biggest one first. So the 384 factors now, I know, into 64 multiplied by 6. We split this up then into two different radicals, the square root of 64 times the square root of 6. The square root of 64 is 8, and the square root of 6 can't be simplified. And that's your answer there, guys, which is what we were looking for all along. Okay, so I want to make it clear there's no magic trick to look at this number and go, oh yeah, 64 is the perfect square that works. You just have to cut the number in half and then just go up the list from there. Now, I wanted to talk about number 5 with you as well, because I could see this being a problem that people would ask about. The square root of 30 is what we're working on right now, and we would like to try to find a perfect square that divides evenly into that 30. Well, going back to my list, 0, 1, 4, 9, 16, and 25, and there's no point in going anything bigger than that because those numbers would all be bigger than 30. Let's go through our method again. We would start off with 30, we would cut it in half, and that would give us 15. 15 is not in our list of perfect squares over here. So we start looking, forget the 25 and forget the 16 because they're too big, and we start on the 9 here and we see what works. Well, 30 divided by 9 does not work out evenly. 30 divided by 4 does not work out evenly. And once you get to 1, guys, this is interesting here, 0 and 1 are perfect squares, but you really shouldn't bother thinking about them because they don't help us at all when we're trying to simplify radicals. What that means is that there's no perfect square bigger than 1 that divides evenly into 30. That means that this radical cannot be simplified. And so you end up then with the square root of 30, which is already in simple radical form. This doesn't happen very often, but there's no guarantee that every radical out there can be simplified. Just wanted you guys to be aware of that. And then I wanted to do number 9 with you as well. Now, I didn't do one like this in our notes here, guys. We've got 7 times the square root of 108, and we hadn't done one yet where there's a coefficient out in front of the radical. Well, the good news is all we're going to do here is leave the 7 out in front and then go about business as usual when we try to simplify the square root of 108. So again, guys, if I'm making my list of perfect squares, it's really not worth writing down the 0 and the 1. We really should be starting at 4, 9, 16, 25, 36, 49. I'm going to put a 64 there, but I think that's as far as I need to go. Now, we look at our radicand here, which is 108. We cut it in half, and that gets us 54. That means that 64 isn't worth checking because it's too big, and likewise, anything else bigger than 64. Forget about it. So let's start with 49 and go from there. 108 divided by 49 does not work out evenly. So forget 49. 108 divided by 36, this isn't something I would expect you guys to know off the top of your head, but when you plug it into your calculator, you see that 108 does divide evenly by 36. It becomes 36 times 3. Okay, so step 2. Again, we split the radical, but once more, just keep the 7 out in front. The 7 gets multiplied by the square root of, by the square root of 36, which gets multiplied by the square root of 3. And again, one of those radicals can be simplified. This is now a 7. It gets multiplied by the square root of 36, which is 6, and you can't do anything with the square root of 3. Now, the one thing we have to do here that we didn't do before, the 7 times 6 out in front of all that can be simplified. 7 times 6 is 42, and the root 3 just tags along for the ride. So 42 root 3 is how you express 7 times the square root of 108 in simplest radical form. Okay, hopefully the other 9 problems there on that worksheet make some sense. If you guys have some questions, post them in the comments and I'll add those as well.